see why? You need to find, yours has better directions than mine. It says find the height, right?
Yeah.
Okay, so you're looking for this piece right here. This is your hypotenuse. That's the H part. Sine and cosine use hypotenuse. Tangent does not. So you're going to want the tangent here. Okay. And again, round 3 decimal places. Let's just call it an even 3 decimal places. Olivia, you have your homework?
Yes.
Okay. All right. This guy, it's kind of a nice little diagram for a little right triangle. Drop your right triangle in there. They want to know how deep is the submarine. So the depth here, the depth is from the top down. So there's your right triangle. Okay. And remember this angle of depression, because this, if you extended your parallel lines, because this angle of depression is here, these are your alternate interior angles. Your angle of depression is actually your angle of elevation. Okay. If depression always starts at the top, keeps the horizon, and looks down. So now we wanted to know how deep. We wanted to know this part. So we've got a hypotenuse and an opposite side. So you've got a sine. Make sure your calculator's in degrees. Good. Okay. Then you had to draw this kind of an A-frame thing. Make an A. Make the sides across the triangle. It stands 28 feet high. There's the height. And it has a base of 20. So it cuts the base in half. Because it's the same on both sides, it says isosceles triangle. The base angles are also the same. So what is the angle of elevation to the roof? Here's your angle of elevation. And that's using an opposite and an adjacent side tangent. Everybody can find the angle?
Yep.
Mm-hmm. Can you put your angles in degrees, minutes, and seconds?
Mm-hmm.
Everybody can do it, okay?
With my calculator.
Oh, yeah, yeah. Well, you could do it with this as well. This one? A long diagram here to make this little triangle right here. So, here's your hypotenuse. Here's your bottom side. They want to know, find the change right here. Here's the change. Like how high is this going up? What's the steepness? They're almost asking for the slope. If you figured this on like an XY axis, it's almost like looking at the slope. So they want this piece right here. So they gave you this degree in here. That's where the 9.5 came from. That's your angle. So this is the opposite side, and the hypotenuse, you want the sine. It kind of gives an application to how do I figure out the change over here. Make a little bit more sense? Their triangle is right there. Uh-huh. Good? Okay, now this was the tough one. This was like the one we did in class.
Oh, I got that wrong.
Well, this is just like the one we did in class. Use your angle of elevation to come from your angle of depression. You can kind of see your two triangles right in here. If you have to, separate them. Here's one. This stays consistent, this 50. This angle comes from this big guy. Wouldn't it make sense that if you're closer, picture yourself looking at something, looking at the top, and then moving a little closer, and then having to raise your eyes, right? So if you're closer, isn't your angle of elevation bigger? So this is the big one, 6.5. Then do this again. This guy is where my 4 is. This stays consistent. So they want to know the distance between here. The distance between here. So if you're looking for a horizontal distance, you're going to find your distance for this guy. I don't know which one I called which. This is Y. And then your distance for the whole thing. This was Z. And then I said Z minus Y equals this little guy right in the middle. Set it up like this first. You're both moved. So two boats were standing apart. The closer one has a higher angle of elevation. If you're closer to something, you have to raise your head to look up. So just separate it into two triangles. Find this piece. I think we said this was Y. We said this was Z. And when you subtract the two, you're going to get the difference of X. This was a great problem like when we did law of cosines, law of sines, and we found the common part, and we found another piece over here to the not right triangle. But because you have two right triangles, you're just going to do right triangle trig and make life simple. Okay, again, make sure you round to 3 decimal places.